So in this video, we will going to discuss the two other approaches for generating a unique ID. So let's start with ticket server. So ticket server was basically developed by Flickr. So what is a ticket server? So ticket server is basically a centralized single, let me write it in the next line. It is a centralized database. It is a single database with single database server with single database, and it works on the auto increment feature. So with these three characteristics in work, it generates the unique ID and then it distributes this unique ID into multiple web servers. So if you look into the diagram, so let's say this is my server 1, this is server 2, and like there are n servers which are dependent on this ticket server. Let's say this is my ticket server, which is a single database server which has a single database for its unique ID. So this ticket server generates its unique ID whenever a server 1 requests for a unique ID, and it sends those unique ID into the multiple servers. So basically, if you look into how Flickr designed this ticket server, so this single database has multiple tables. So like tables are like this is ticket 32 table, ticket 64 table. So each table generates a 32-bit unique ID. It generates a 64-bit unique ID, and like that there are multiple tables in a single database. So the advantages of using this ticket server is like, if I write down, so it has numeric IDs, unlike the UUID which I discussed in the previous video. It has numeric IDs and it is very easy to implement. Since it is a centralized system, it works on the auto increment feature, and it is a single database, so it is easy to implement. But one of the major drawback, as you might have guessed also, since this is a single database, so the major drawback is single point of failure. So if single ticket server goes down, then the web servers, even if they request for a unique ID, they would not get a unique ID, and thereby all the dependent systems would face an issue. To avoid this single point of failure, what Flickr did, like they chose the option of high availability, and thus they introduced two ticket servers to handle this issue, and data is synchronized between these ticket servers. So in these two ticket servers, how they implement is like, their server 1, this is ticket server 1, so it has an increment feature. Let's say this is 2 and offset is 1, and there is another ticket server 2 which is also dependent on increment feature. So let's say this is 2 and offset is 2. This thing which I have seen in also multi-master application, this notations of how we denote this offset and how we denote this increment. So in this way, the Flickr implements two ticket servers, and a load balancer is used in order to communicate between these two servers and to handle the downtime. If any one of the server is down, another server is up, so it can generate the unique IDs. And by this, Flickr is able to give service to their clients by using two ticket servers, by handling the single point of failure issue. But this works for a small or medium scale enterprises. So this is another drawbacks is like small or medium scale applications. For large applications, now we will see another method to generate a ticket server, another method to generate a unique ID, which is currently in use. This is Twitter Snowflake approach. So the Twitter Snowflake approach was used because it, in order to keep in mind that it can generate tens of thousands of IDs in a second. I'll attach the link about this article and also about the Flickr article which I just discussed in the description box. You can read it in details about them. So in a high level view, Twitter Snowflake approach, it had the criteria in mind that it should generate 10,000 IDs in a second, which is also a requirement, and it should be generated in a web server as they are shifting to using Cassandra or key value store databases. So generating ID would cause a latency in the database. So web servers generating databases, web server generating IDs. So in this way, Twitter Snowflake approach handles all these criteria, and it basically uses a divide and conquer approach. So what is it? This is basically, so it has a 64-bit. It is a 64-bit ID. It generates a 64-bit ID, and this ID 64-bit is divided into certain segment. So this is 1 bit. Next we have 41 bits. Then we have another 5 bits, another 5 bits, and the last is 12 bits. So this is basically a sign bit which can be used for future references, not used currently. And next is like we have this timestamp of 41 bit. Then we have the data center ID, we have the worker or the machine ID, and then we have the sequence number. So timestamp is, so if I go individually, this is a sign bit, this will always be 0 for a current scenario, and it can be changed to 1 if for future reference if it is required to distinguish between signed and unsigned numbers. Next we have this timestamp of 41 bits. So it is in milliseconds and it works on the epoch. So Twitter has chosen its epoch of November 4, 2010, and the time is like 1:42:54 UTC. So basically whenever we represent the timestamp in a binary number and we convert it into a decimal number, this timestamp is converted into a Unix timestamp and is added to that decimal number which we got from the timestamp's binary number, and then we can convert it into UTC to get the current timestamp when this unique ID was generated. So in this way these things work. Then we have these data center IDs, the data center or in which the web server is located, and particularly, and in this way we can put the data center ID. Then we have the machine ID or the worker node which generates the unique ID, and then we have the sequence number or the thread which works in the worker. So this is the worker node, and this is the sequence number generates the threads basically which is running in the worker node to generate the particular ID. So this is this number is reset. So if I go, so sequence number is reset to 0 to every millisecond, in every millisecond. And as you can see, these are 5 bits, so it can hold 32 different values, data centers. It can have 32 machines per data center, and these can have 212, so it's like 4096 sequence numbers can be generated in a millisecond. So these are the particular bits which represent a 64-bit Snowflake approach of generating a unique ID. So this data center ID, and to dive deep into it, like this data center ID and machine IDs are chosen at the startup time, and generally these are fixed and these do not change usually until and unless some accidental change in these values happens that might lead to a conflict, and then we have to refix these values. And timestamp and sequence numbers are generated when the ID generator is running. So basically the machine is working, the ID is being generated, and these sequence numbers are being generated. And the sequence number are generated usually in, this value is basically 0 in every millisecond. If there more than one unique ID is being required to be generated within a millisecond, then this value changes, but it is usually 0. So these are all the various approaches which we have discussed in deep about them to generate a unique ID in a distributed system. I will post the links related to them, some articles you can go through if you are interested, in the description box. So yeah, thank you for watching this video. Thank you for watching this series. See you in the next video or in the next series.